there is a rectangle ABCD, and then they say that BE is equal to 8, CE is equal to 15, while BC is equal to 17. And then our final target is find the area of this rectangle. That means if we have the base of this rectangle, what is missing is the vertical height. We want to know what is the corresponding height here. One thing very important is about Pythagoras theorem. If you have enough practice, you should realize that 8 to 15 to 17 is one of the common ratio for right angle triangle. We may consider 8 square plus 15 square, and then we are going to compare it with 17 square to see whether they are the same. 17 square is 2 8 9. Since this line square plus this line square is equal to the hypotenuse square, that's why by the converse of Pythagoras theorem, this is right angle. And this is very important to find out right angle is because we can use the basic trigonometric ratio for right angle triangle. Remind you that our target is to find out the right angle triangle and the height here. So therefore, it's very important to know about this angle. If we can use this angle together with the sine ratio with 8, then we can find out the height. In the first stage, we need consider triangle BEC. To this angle, this is opposite side. To this angle, this is hypotenuse. So I know that sine theta is equal to 15 divided by 17. You may write down cosine theta or tangent theta, but this one is more straightforward. And then later on, our target is the height, so I write down h here. Now, our focus is the red triangle here now. And then consider theta. Our height is the opposite side, while h this time is the hypotenuse of the red triangle. Therefore, we consider the sine ratio theta again, which is h divided by 8. Our target is 8 times of sine theta. And because sine theta we already found, sine theta is 15 divided by 17 because they are talking about the same angle. We have 120 divided by 17 is the height. Finally, to get the area of a rectangle is equal to BC and then times h. BC is 17 while h is 120 divided by 17. It's cancel out each other and only 120 is left. Therefore, our answer is C. This is not a very straightforward method because we need to use a trigonometric ratio as a transition. Indeed, it's not necessary. You may just directly focus on triangle BC, similar to a smaller triangle. This time we may let A, B, C, D, E. We let this point be F. We are talking about BFE. They are similar is because right angle and also a common angle. So this is 8 to 15 to 17, while FE is H. BE is 8. So we know that 17 how to become 8. The transition is we divide by 17 first and then multiply by 1. So if we multiply this factor, we can change 17 to 8. Similar reason, from 15, we divide by 17 and then times 8 times. So 15 and then multiply this factor will give you h. We give h is 120 divided by 17 directly. Then the following are the same here. And basically, trigonometric ratio is an application of similar triangle property.